Okay, let's take a look at the product rule. So you should just make sure that at this point you're quite fluent now with the chain rule. So for example, you should be able to get these results here. So what is this? This is 4t to the half, effectively. So half bracket minus half multiplied by what's differentiated inside is 4. So 2 4t minus 1 to the minus a half, for example. Okay, as well as these results, what did we say? We said number part. So same again, natural log of the number part, for example. Same again, natural log of the number part, and sometimes that 3 might be brought down here, or you could leave it up there, and so on. Right, the product rule then is when you have a product of two functions. Okay, let's just check the audio is still on. Good. We've got the product of two functions. So u is sort of the function of x that's on the left. So this could be like some function of x. And v is the function of x, a different function of x that's on the right-hand side. And they sit next to each other. In this situation, we use this rule here. Okay, we don't need to go into the proof for why it works, but that's certainly something you could look into. What we need to do is we need u, this is the same u as before, multiplied by the derivative of the second part, plus the second part multiplied by the derivative of the first part. So the way I like to answer these questions is I sort of like to do something like this. List out my u and my v, and I call these du and dv just for convenience here. So u is the one that's on the left. So for example there, u would be x squared. V would be sine x. Okay. I differentiate each of them, 2x and cos x. And then the rule says u dv. Well, u dv means these two parts. So u dv is x squared cos x plus, and it's the other two. Okay, so I remember it as diagonally this way and then the other two this way. And if you do it like that, it's quite quick. Okay, so this is a rule that works when you want to differentiate two functions of x that are written as a product. Let's do another one. X e to the 2x. So a bit limited on space, but what you would do is u equals x, du equals 1, v equals e to the 2x. Now, what's e to the 2x differentiated? There's actually a chain rule inside there, isn't there? But you've learned this as a result from year 12, so many of you will probably be quite happy if I write that like that. Okay? Now, u dv, that will be these ones. So x, or 2x, e to the 2x, that will be when it's all together. And then this will be a 1 times by e to the 2x. So if we put that all together, we get this one here. Okay? It said find the turning points. So this is just showing you that the question can turn into sort of like a, one of these other sort of types of questions. So we set it equal to 0. If you factorize it, you get something like that. Now, this is worth making a point of, and this has got a yellow box to flag up something that harder exam questions do. So when you factorize something out, it's a bit like sort of at GCSE when you had something like this. When you have two brackets multiplied by each other and the answer is 0, what it must mean is it must mean that one of these brackets, or both of them, but one of them, if we got 2 and minus 3, one of them is equal to 0. Well, it's a bit like that. This one must be equal to 0, or this one must be equal to 0. But remember, we know what exponential graphs look like, and we know that they can never be equal to 0. They get close, but they are never 0. So because of that, we know that we need to solve this bracket, and we get this minus a half. So that's quite an important idea there. Okay, so x as minus a half to solve. The e part is not where the solution lies. Let's do another example, which is a bit more complicated. So the trick is to separate the u and the v parts carefully and to think about them bit by bit. So e to the 4x, that's a function of x. Sine squared 3x, that's also one other sort of function of x. So e to the 4x, and then this bit, this is more complicated. I'm actually going to change how I write it. I'm going to write it as sine 3x being squared, like that. Okay? Well, we know that we need the different pieces because the rule is u dv dx plus v du dx. So we know we need to work these ones out. Well, this one, this is technically a chain rule. That's 4e to the 4x. Yeah? And what about the v one that becomes dv? Well, there's a chain rule in this one as well. So it's actually a triple chain. If you start with the innermost bit is 3, and then sine becomes cos of bracket. Well, bracket here is 3x. And then there's the outermost thing, which is bracket squared. So bracket squared becomes 2 bracket. And what should the bracket be? It should be sine 3x. Now, that's quite a lot to do as a big step in your head. So you might want to handle that. If I just write it like that, you might want to handle that by breaking it up into parts, okay? But ultimately, that's what you would get. And then when you have your pieces, it doesn't matter that the pieces are very complicated, okay? They still get put together. The same will go together, and then they will go together, okay? And eventually, look, it's meant to look like this. So looking ahead, something with cos and sine and 3x and so on, what we have kind of looks like that. So UV, UdV will be, there's the U part. The dV, I'm going to put the 6 at the front, and then I'm going to put the sine 3x, cos 3x bit all together. So that's the first part. That's this part here. That's meant to be a 4. The V is this bracket here squared. But we tend to put numbers and e's first. So I'm going to put that part first. So 4e to the 4x. And what would that be? Well, if I write it back in its original form again, sine squared 3x, it would look something like this. The issue is, though, it's written in some other way, so it seems like they factorized something out. Can you see that sine of 3x? Well, maybe we should put it back. Sine of 3x appears in both of them and can be taken out. And e to the 4x appears in both of them and can be taken out. So if you take e to the 4x out and also a sine to the 3x, what would that leave you with? Well, it would leave you with a 6 and a cos 3x. Check your answer. Check that everything multiplies back. And a 4, and you're losing one of the sine 3x's, but you'll have another sort of power of it still left over, sine of 3x. And there we go. Okay, so that's quite a complicated example, that one. The product rule is all about separating what these pieces are, but then when you're finding those pieces yourself, you might have to do like a lot of chain rule, for example. So it helps to think of product rule and quotient rule as sort of like big level rules where you set up the pieces and you get ready to put them together. But inside that, there might be other things, like you might have to use E, you might have to use chain rules, you might have to use trig. You have to know all those other results. So you're not really able to do this until you have a really strong grasp of the chain rule. Let's do one that's a little bit easier then. So this means differentiate still. So u and v, du and dv. U is x squared. This part here, I'm going to write this as 3x minus 1 to the power of a half. Du becomes 2x. Half bracket minus a half with the bracket. And then you have to multiply by inside differentiated. That's just a 3. So I'm going to jump to multiplying it by 3, and it will look like this. These together, then these together. So 3 over 2, I'll put the x squared after the 3 over 2. 3 over 2x squared, 3x minus 1 to the minus a half. That's the u dv piece. The v du, it's going to be these multiplied by each other. So I'll put the 2x at the front and then I will put the bracket. Okay, and we are finished. We could factorize perhaps or something, but it doesn't say that we need to. So pause the video and have a go at these questions here. Word of caution, watch out for the natural log of 3x. Okay, that's a special result there that you need to know. So pause the video and have a go. Okay, so I'm assuming you've had a go there. Your u piece should be x squared. Your du piece should be 2x. The natural log of 3x. dv is actually 1 over x. Okay, doesn't matter if there's a coefficient of that x. If it's being natural logged, it's just 1 over x. U dv is going to give you x. Okay, and v du is going to give you 2x natural log of 3x. So there we go. Okay, that's your 2x natural log of 3x, and there's your x. They've written it the other way around. Other question here. So this is more difficult. We have to differentiate. And what could we do? Well, we could rewrite this. This is probably, I'm trying to think of the best way to do this. I mean, I suppose we could do this now. So I'm going to call this bit here 6x, but it's in the denominator, so I'm going to call it 6x to the minus 1. Okay. Then my other piece here, I have x minus 1 to the half, but it's to the minus half. So why don't you pause the video again, have a go at calling this bit u, and have a go at calling this bit v, and see if you can get the answer. It is very much a challenge, though. Okay, this is a disproportionately difficult question. Okay, so when you do that, this is the same what they've written here. We're able to generate this one. So write the different pieces out carefully. U and du, v and dv, some manipulation, so on. It will take you a while, but you should be able to get that result there. Okay, it requires that you're very, very good with your indices and things like that. And that takes you up to the end of 9D. So you're ready to have a go at some questions on the product rule.